Welcome to the UGC EPG Pathshala lecture series in computer science. In this series of lectures, we have been looking at database management system. For today's session, I will be talking about client-server databases. Learning objectives of today's session include to create a client-server environment, to mention on the application logic components, to introduce on file server, database server and client-server technologies, to mention the challenges faced by the architecture of client-server technologies. In general, to talk about the client-server systems, generally the client-server systems operate in a networked environment. The processing of an application distributed between front-end clients and the back-end servers. So, having said a client-server system, there will be surely a server which serves at the back-end and there will be a client machine which serves in the front-end users. So, the client process requires some resource which the server provides to the client. So, whenever a client requests for some service to be done, that will be present in the server will respond with those services to the client and the client will start processing on the information. So, clients and servers can reside in the same computer also. I can call my machine as a server and at the same time this can be utilized as a client also, or they can be on different computers. Say my machine is used only for using the interfaces, and every time when I post in a query or service is requested, it goes to the server which is another machine and the machine will respond with that answer which I can view it from my machine. So, a client and server can either be a single machine or it can be two different machines at two different places. So, what does a client mean? A client can generally be a workstation or usually be a personal computer that requests and uses a service. So, the general purpose of a client is to request a service to the server, or the service that has been granted by the server will be used at the client's end. So, client does only that limitation of processing, and a server is usually a personal computer, as I have told you already. It can be a same computer, personal computer or a mini frame computer or a mainframe computer that provides a service. So, anything which provides a service will mainly act as a server. So, for database management system, the server we will call it as a database server. So, in order to comply with client server architecture scenario, we may need to understand three different logics. So, three component logic of application systems include input output or presentation logic component. The first of this logics, application logics, include input output or presentation logic component. This component is responsible for formatting and presenting data on the user screen. So, anything which need to be represented as an interface to the users, so those will be at the input output or presentation component. And managing users input from the keyboard, anything that is to be keyed in from the client's end will be considered as input output processing. The second of its kind would be on a processing logic. So, anything that the user feeds in or anything that the already existing as user interfaces on a mouse click, so those are to be taken at the next level for processing the information. So, this processing logic mainly handles data processing logic, that means validation and identification of processing errors. It not only that, it in turn calculates the business rule logic also, anything which is written as business logic. Say I book a train ticket or I book a flight ticket, although I give the source and destination, but then I wanted to have return dates, but I wanted both the tickets to be at an economic rate. So, I may have to fix with my budget, say any tickets to and fro should be within 10,000. So, that requires another logic, so that becomes a business logic purely, and a data management logic which is identified the data necessary for processing the transaction or query. So, at the processing level it is quite important, we may have to process with three different things. One is on the validation and identification of data that is required for processing. Not only that, it also looks after the business rule logics and data management logic. So, three things we will look at from the processing logics end. And the third level of the application logic includes storage component logic, which is responsible of all the data that is getting stored and retrieved from a physical storage device. So the main purpose of DBMS is happening here. So all the activities of database management system happens only at the third logic, which is the storage component logic. So to talk about the client server architecture, it initially started with a file server architecture, then went on to a two-tiered architecture like database server architecture, and went on to a three-tiered architecture. If you look at these three architectures, whatever that we have studied as part of database management system, like starting from a physical layer, conceptual layer and an external layer, they formed a part of three-tiered architecture. But client server, although it is sounding to be a three-tiered architecture, but then it complies with the three modes or three logics, application logics that we were talking about, like input, output or presentation logic, or processing logic, and even a file server, storage logic. If you look at the hierarchy of presentation of the client, as far as file server architecture is concerned, where the client will do an extensive level of processing. So the component of the involvement of the client will be too heavy at the file server level, at the client level, at the file server architecture scenario. Whereas when we go higher to a three-tiered architecture system, where the server does a major process of the work, whereas the client does only limited processing. To talk in detail about file server architecture, the first client server architecture being developed is the file server architecture. All processing will be done at the PC that requested the data, that is, client handles the presentation logic, the processing logic and much of the storage logic. That means out of the 100% work that need to be done, see, every logics that we have seen, application logics that we have seen, like presentation logic, processing logic and the storage logic, more than 80% of the job will be carried out at the client's end itself. So that is what I am trying to say here. All processing is done at the PC that requested the data, that is, client handles the presentation logic, processing logic and much of the storage logic. A file server is a device that manages only the file operations and is shared by each of the client PCs attached to the local area network. Each file server acts as an additional hard disk. So whenever I am talking about a file server, every file server will be acting as an extra hard disk, which will be present not only at the server level and which will also be present at the client side for each of the client PC. Each PC may be called a fat client because this client does an extensive work. Based on that, I am calling this client as a fat client. So most of the processing, since it happens at the client side, it is called a fat client. Entire files are transferred from the server to the client for processing. So anything that the client has requested, that query will be taken to the server and the server will respond all the possible states back to the server without any processing, and the client, after the client receives all the service or the files required for process, the client executes everything and it will be called a process. So this is the complete architecture of a file system, file server system, where if you look at this machine, all the clients are connected by a local area network to a file server. This file server in turn manages all the data. So if you look at the major responsibility of a client and the responsibilities of the server, client does processing and scanning of tables, client does application program user interface. Not only that, client does data processing, client generate queries, handles integrity, that means it checks for the validation of the data, and it also checks for the identification of from which node it has come from. So it also have to handle security aspect of it. So that means almost all the process is taking at the client's level, so it maintains the copy of DBMS that is available in the server. At the same side, if you look at the file server architecture, the file server looks after the storage of all the files, and locking of records acts like an extra hard disk to the client, and this will not be very busy because many a times I am not transferring all the information. Many a times I just from the server's end I am transferring the information to the client and I do not process with the information. So it is not very busy and it has got significant LAN traffic. So when you look at the entire architecture, although many machines are connected to the server, the responsibility of the server will be any request that I get from different client machines, I push all the data from my end to the client's end. It is the responsibility of the client to take up all the data that is available in the server, process whatever which is required for the client to execute. Those will be done at the client by itself. So if you look at the networking system, the client can request for a data, a request to log the data, and from the server it will be given back where the entire file of the data will be transferred to the client and the log status will also be given to the client. Say log like read, write logs. Once the client requests, it means it is trying to read from the server, so it logs. So whatever information that is to be read, maybe it could be put as a shared log or an exclusive log, where in case of a shared log many clients can request to the server what are the information that the client requests to read from the server, and if it is to be an exclusive log, if it is from the server's client's end, it will be logged at the server, then the client after transferring all the information to the client, then the log will be released. So those information will be handled at the server's level. So as I have already told you, this file server architecture, since most of the work is being carried out at the client's end, that means out of the 100% of the job, 80% of the work is being done at the client's end. So I call these type of machines as fat client machines. Every system will have its own drawbacks. So in this file server architecture there are few drawbacks, where in case because of transfer of information from the server to the client as requested, there will be a huge amount of data transfer on the network, because when a client wants to access the whole data table, in case the client wants the whole data table to process on a simple information, then the whole data will be transferred from the server to the client. So this has to be transferred to the PC. So the server is doing very little work. That means the server locates where the table is, transfers the entire table to the client machine. So server does only little work, network is transferring large blocks of data, and the client is being busy processing all this data with an extensive data manipulation. So that seems to be one of the disadvantage. And the second issue that raises because of the file server architecture, each client is authorized to use database management system when a database application program runs particularly on that personal computer. Thus there is one database but many concurrently running copies of DBMS, one on each active PC, so heavy resource demand on a client's. As requested previously, the same table might be requested by many clients at many different sites. In that particular case, I will be running on the same table at different locations, concurrently running the same copy of information at different locations. So there will be a heavy resource demand for a particular table from a server. The third issue that we wanted to point out was the DBMS copy is in each client PC must manage the shared database integrity. That is, client database management systems must recognize whether it could be shared log or integrity check, which is for validation, and all these are to be checked. Only then, after assurance of all these things, it will be taken for consideration, because security is also a major aspect of the client. So the programmers must be sophisticated to recognize various subtle conditions. So any specific condition where this might also may lead to a risk will also be handled by the programmer's end. That can arise in a multiple user database environment, as to understand overview of concurrency, recovery and security controls and build these into their applications. So those were some of the issues that we have pointed out with file server architecture. So because of such issues, we wanted to reduce the load of the client and wanted to switch on to the next level of architecture, which is called a database server architecture. So after the file server approach came this two-tiered approach, which is called a database tier approach. Client is responsible for managing only the user interface, IO processing, data processing, and some of the business logic rules. That means at the front end level, I will be doing only certain quantum of job which the client could take up responsibly. That means I can take up a job which is at the application logic, like managing user interface. Then I move on to the processing logic for IO processing, data processing, and business logic processing. So anything which limits itself with the first two components of the application logic, that means input output or presentation component and the processing component, and this has nothing to do with the storage. So storage is the entire responsibility at the server's end. So client does only the first two levels and server will take care of the storage at the next level. So database server performs all data storage and access processing, that means all the backend functions, whereas the database management system is completely on the server. So after doing this kind of a database server architecture, that means a two-tiered architecture, some of the disadvantages of this particular system include clients do not have to be as powerful as it was with the file server architecture. So only the database server requires processing power adequate to handle the database. Only the capacity of the RAM, not specifically on the ROM, need to be too heavy. It is with the clients only the RAM need to be too heavy for processing all the logics that the server has provided with. So therefore the server can be tuned to optimize data processing performance. So this significantly has reduced, because one of the issue that we have pointed out during our file server architecture was the complete data getting transferred not only to one client, concurrently accessing the same data values by different machines might cause a heavy data loss, heavy data traffic. So that is getting significantly reduced. So this greatly reduces data traffic on the network, as only those records that match the requested criteria are transmitted to the client. So this improves data integrity since it is all processed centrally. So server maintains the complete data, which is like a centralized database management system. As and when this is requested, it goes into that particular machine, then it processes. So at this juncture we may have to understand about stored procedures also. So these stored procedures are nothing but modules of code that implement application logic which are included on the database server. So they have certain advantages. The advantages include performance improves of compiled SQL statements, reduced network traffic as processing moves from client to the server. Thereby, by using stored procedures, we can improve on the security if the stored procedure is accessed rather than the data and code being moved to the server. Not only that, this improves data integrity as multiple applications might access the same stored procedures. Compared to the file server architecture where it was called a fat client, now it is called a thinner client, because client does a minimal level of processing when compared to the fat clients. But then for storage, the server size has to be very large, so the server becomes fatter. Some of the disadvantages of using these stored procedures into this database server architecture: writing stored procedures takes more time than using something like Visual Basic. Proprietary nature reduces portability. Performance degrades as the number of online user increases. So this is the architecture of a database server, where with the previous concerns I am giving the same set of clients connected over a network, local area network. There is a database server instead of a file server, which takes up the responsibility of storing all the data values, and the sole purpose of the database management system is to store all the values and to retrieve and feed it back to the clients. So this makes the client do only certain level of work, that means at the application logic level first two will be done at the client's end. So this become thinner clients. Then we march on to the three-tiered architecture because of some of the disadvantages that we had in the database server architecture. So we thought for every level of logic, application logic, there should be one server which can process on that type of information. So this three-tiered architecture helped for those scenarios. In general, these include another server layer. So what I am trying to put is, instead of one DBMS server, I am putting one more server which can take up effectively on the processing. This processing, if it happens at the server, many clients might access on a particular data, at the same time I wanted to process on the data which might change the records that is available in the server. So instead of that, one copy of the database will be maintained at the database management server, and the other copy will be stored at another server level, which now I will call it as an business logic server, and business logic server will act on all the logics which are provided by different clients and will respond them back with the same values. So this will be an additional server which will be like a backup server. So in general, these include another server layer in addition to the client and database server. So this additional server may be used for different purposes. Often application programs reside on the additional server. Any application programs that comes to the business logic server, executes it, it does not carry it forward to the database server. Business logic requests the database server for any queries and takes the table back to the business logic server. This database logic server in addition may hold a local database, whilst another server holds the enterprise database. This is often called a thin client PC just for user interface. So if you are about to switch to this kind of a system, these are called thin client machines, where the system will have its own operating system to boot, and the rest of the thing will be responsible at the different server levels. So just for user interface and a little processing, application processing, limited or no data storage, sometimes no hard disk also. So it will boot on its own, and every level of processing that it has to do, it completely depends on the business logic and the database server. So this you would have sometimes seen in most of the railway stations, where where the ticket booking office will have just the monitors. They will boot the machine, they will have the interface, they click and see to that the ticket gets printed from the server. So they have to have only the monitor and the printer connected to the area, and any ticket that has to be printed, if I am to use only the user interface, then the ticket gets printed. I do not have to process on any of the logics, and I am not authorized to proceed with any other processing at the next level. So this is the three-tiered architecture system, where as shown before, different clients are connected to the local area network, but then I have introduced one more layer which is called a business layer, which acts as an application server, and there is an additional server which is called a database server also. So this type of system is called a thinnest client system, where client does only limited processing, and this client does not require a CPU for it to get processed. So the business rules are on a separate server, this is on a business logic server, and the DBMS will reside only on the database server. So whenever a client requests some information, to process on the information, this will in turn get into an application server, and application server will in turn request the database server through the same network connectivity. Then the database server will respond with those records which the application server has requested. That will get processed on various business logics on the application server, which will be fed back to the clients as an output. Some of the advantages of using this three-tiered architecture include: point number 1, it will be very scalable. So middle tier can be used to reduce the load on the database server. So that means the application server can reduce the load of the database server. At the other end, when you look at it, reduces the complete effort of the client also by using a transaction processing monitor to reduce the number of connections to a server. An additional application server can be added to distribute application processing. Not only that, another advantage of this 3-tiered architecture include long-term cost reduction. Use of off-the-shelf components or services in the middle tier can reduce costs, as can substitution of modules within an application rather than a whole application. Better match of systems to business needs, where new modules can be built to support specific business needs rather than building more general and complete application. Many times we will not be able to create generalized applications. Sometimes client might request applications which are slightly modified and as per their requirement. For those sort of requirements, it is to be stored at the application server level itself, so that anything that is requested to the application server can easily respond to. If in case if it is connected by a 2-tier network, anything that a client requests, it is getting processed at the server, but then it cannot be generalized. So adding of these application servers might impact a lot, and also it can use for cost cutting. Not only that, the other advantage that we see to the 3-tiered architecture is on the technological flexibility. Because of this technological flexibility, it is easier to change on the database management engine. Middle tier can be moved to a different platform. Say I have an application tier, this tier can be moved to a very different platform, and a simplified presentation interface makes it easier to implement new interfaces, which can often improve the customer service also. So multiple interfaces on different clients can access the same business process. In summary, in this particular session we have looked at client server environment. We have looked at 3 components that are required for the application logic, which are input output or presentation logic, processing logic and storage logic. Then we have started saying about file server architecture, where it will be a fat client. Most of the work will be done at the client's end. Then we looked at some of the issues of the file server architecture, which laid the path to develop the next level of architecture called database server architecture. This is called a thinner client. That also had some of the issues, because of which we laid on the 3-tiered architecture, wherein most of the responsibility of the processing will be done at the separate application server. So another level of server got introduced, so hence it was named the 3-tiered architecture. Thank you.